Okay, let's try this. This is the diagram of the side view. As you can see that the current flowing in the same direction going up, and when you use the right hand grip rule, so we can determine the direction of B. For B1 is into page and B2 is out of page. Okay, how about the second diagram here? When the current both in the same direction but going downward, we can see that the B at point P, for B1 is out of page, for B2 is into the page by using right hand grip rule. So how about the side view, how about the bird view or top view? So you just see from this position. So when you see at this position, so for the bird view, for the current is going towards I, so means that out of page. Same goes with I2, out of page. And then by using right hand grip rule, so you can see that the direction of B for I1 is into page. Kalau you look at top view, arah B ni adalah tangential tu punya rotation, tangential from the rotation of B ni, direction of B. So kalau anak panah dia arah macam ni, so you terus straight kan ke belakang. So ni maksudnya adalah into page. Okay, so seolah-olah macam yang kita tengok ni, ini into, okay, ni page, ni into, ni out. So yang into akan masuk lah. So yang untuk I2 ni, kalau kita buat tangan, kita akan nampak direction dia B macam ni. So bila sampai je point P, kita tangential. So that's why dia macam ni lah. Maksudnya tangential ni dia dengan radius dia 90 degree. Okay, B dia ni 90 degree daripada R. Okay, sambunglah macam ni juga. Okay, boleh Right, so next adalah determine the magnitude of the magnetic field by using equation. Magnitude means kiraan lah. Macam tadi kita belajar, our previous video is how to determine the direction of B for straight wire, circular coil and solenoid. So now how to determine the magnitude for straight wire. So as you can see that by given equation, the magnitude of the magnetic flux density at point P from distance R of the wire carrying current is given by B equal to mu naught I over 2 pi R. Okay, so R, okay, whereas mu is equal to 4 pi times 10 to the power of -7 Tesla meter per ampere. I is the magnitude of current and R distance of a point from the conductor wire. Okay, so for conductor wire, you use this formula. Okay, let's try this. For example, we have two conductor wire, I1 and I2. They are separate with 3 cm and 4 cm respectively. So the equation asks you to determine the magnetic field intensity at point P. So when the equation asks you about the magnetic field intensity at point P, so means include for magnitude and direction. Sebab magnetic field tu adalah vektor, jadi walaupun tak sebut magnitude or direction, you kena faham lah yang you kena cari dua-dua. Okay, so first you kena buat dulu direction of right hand grip rule. So you akan dapati I1 is into page and I2 is pointing out of page. Okay, so I2, maksud saya I2 ni akan hasilkan B yang out of page. Okay, so I1 yang akan hasilkan B dia adalah into page. So kena guna right hand grip rule. Okay, so kita pun calculate lah B1 and B2. So B1 is equal to mu naught I1 over 2 pi R. Substitute the value for each. Okay, pastikan you substitute yang betul lah dan tukar dalam unit SI. So you akan dapat 2 times 10 to the power of -5 Tesla. Direction dia adalah into the page B1. Okay, next for B2. B2 is equal to mu naught I2 over 2 pi R. So substitute the value for I5 ampere and don't forget about radius dia adalah 4 cm. Radius, sorry, bukan radius, kita panggil distance Okay, simbol je R tapi dia adalah distance. Okay, so this the answer is 2.5 times 10 to the power of 5 Tesla. So direction adalah out of page. Okay, so nak kira dia punya resultant B at point P. So B at point P is equal to B1 plus B2. Okay, kita assume yang into page tu adalah positif, out of page tu adalah negatif. Okay, so terpulang pada awak, siapa yang you nak assume? Okay, so saya assume into page adalah positif, out of page adalah negatif. So B1 plus minus B2 because page dia tak sama. Okay, so kita dapati jawapan adalah negatif. Negatif means adalah out of page. So nilainya adalah 5 times 10 to power of negative 6 Tesla. Okay, this is example from the top view. Okay, you can see that the cross here is represent current flow. Okay, so we have to determine the magnitude and direction of the net magnetic field intensity at point P. So I draw already the diagram. Kalau you tengok, bulatan ni menunjukkan B. Macam mana saya tahu arah B ni adalah B, warna biru ni adalah B1 keluar? Kita boleh guna right hand grid rule lah. Okay, you boleh keluarkan lah B1 nilai dia lah out of page. And then untuk B2, cross means current dia adalah into page. So bila you masukkan thumb you adalah into page, so akan nampak ada finger you pusing macam ni. Okay, so dia adalah means out of page juga. Okay, so masuk dalam formula. Okay, substitute the value, and then this one is very important. The distance from point P to the wire 1 is 7 cm. Okay, 7 cm. So dapatlah 8.57 times 10 to the power of negative 6 Tesla. So direction is out of page. Okay, so for B2, I2 is 5 ampere, and then the distance from I2 to point P is 2 cm. Okay, so substitute the value, so we get 5 times 10 to the power of negative 5 Tesla is also out of page. Okay, so out of page kita assume negatif kan. Okay, so B1 plus B2 negative, B1 plus negative B2. So the answer you get is negative. So means that 5.86 times 10 to the power of negative 5 Tesla is out of page, because out of page we assume that the direction for B is negative. Bukan direction of B, the sign of B adalah negative. Okay.